Hello! Welcome to today's lesson on comparing series and parallel circuits. Today we will compare series and parallel circuits by examining the impact of component failure, design complexity, current and voltage behavior, and energy efficiency. So far, you have gained a solid understanding of how current, voltage, and resistance behave in series and parallel circuits. You've learned that in a series circuit, the current is the same through all components, the voltage divides among the components, and the total resistance is the sum of individual resistances. You've also learned that in a parallel circuit, the current splits at junctions, and that the voltage across each branch remains the same. Additionally, we explored how adding more branches to a parallel circuit decreases the overall resistance, providing more pathways for the current to flow. Building on this foundation, we can now compare series and parallel circuits. By understanding these differences, we can better appreciate how electrical systems are designed. Let's get started! Let us now tie up our knowledge and compare series and parallel circuits. Firstly, let's look at the impact of component failure. In a series circuit, all components are connected one after the other along a single path. Because of this, if one component fails or is removed, the entire circuit is broken and current cannot flow. Imagine a string of Christmas lights. If one bulb burns out or is removed, the entire string goes dark because the current is interrupted. This makes series circuits less reliable for systems where constant operation is crucial. In contrast, a parallel circuit has multiple paths for the current to travel. If one branch fails, current can still flow through the other branches, allowing the remaining components to continue functioning. This is why parallel circuits are used in home wiring. If one light bulb burns out in your house, the others remain on, and other appliances like your fridge and TV continue to work because the current flows through other independent paths. Next, let's observe the balance between design simplicity and complexity. Series circuits are simpler to design and build. Since there's only one pathway for the current, you don't have to worry about creating multiple connections. This makes them useful for applications where simplicity is key and where the operation of one component depends on others, for example, simple battery-operated devices. Parallel circuits are more complex to design than series circuits because they involve creating multiple branches or pathways for current to flow. However, the added complexity provides significant benefits in terms of reliability and independent control of each component. Let's look at voltage and current behavior. In a series circuit, the voltage supplied by the power source is shared across all components. The more components you add, the lower the voltage each component receives, which can affect performance. The current, however, remains constant throughout the circuit, so all components experience the same current, regardless of their individual resistances. This uniform current can be a drawback if the circuit includes components that need different amounts of current. In a parallel circuit, the voltage across each branch is the same as the voltage supplied by the power source. This means that all components receive the same voltage, which is crucial for household appliances that require a specific voltage to function correctly. However, the current is divided among the branches. If one branch has less resistance, more current will flow through it, while branches with more resistance will receive less current. Finally, let's compare energy efficiency. In a series circuit, the addition of more components increases the total resistance, which can reduce the efficiency of the circuit. This is because the voltage is divided among all the components, potentially leading to weaker performance, especially as more components are added. Parallel circuits tend to be more energy efficient when multiple devices are in use because the voltage remains consistent across each branch. The current is shared according to the resistance of each branch, which allows for more efficient distribution of power, especially in larger systems like home wiring or industrial applications. In summary, series circuits are simpler, but have the drawback of being less reliable because a failure in one component affects the entire circuit. Parallel circuits, though more complex, offer flexibility, reliability, and consistent voltage across components, making them ideal for household wiring and other systems where independent operation is critical. In today's lesson, we compared series and parallel circuits, examining impact of component failure, design complexity, current and voltage behavior, and energy efficiency. By understanding the differences between series and parallel circuits, we can better appreciate how electrical systems are designed. This knowledge equips us to identify the best circuit setup for different needs, ensuring that energy is distributed effectively and that systems function smoothly.